Continuing on with quadratics on our first day of polynomials, we are going to now look at some other key points that we're going to investigate. So here we have a basic quadratic, x squared plus 2x minus 8, and we're going to take a look and find the axis, the symmetry, vertex, x and y intercepts, and then graph. So this is a little bit of an add-on on what we did on the previous part 1. So again, I'm going to take this and I can immediately find the y-intercept of 0, negative 8, and I can graph that puppy. So I'll go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8. Should have had that pre-done. There we go. And that's about all I can really do. I know it's going to open up, but let's go ahead and complete the square. Now I'm going to start doing this because, again, hopefully you've been doing this since Algebra 1. I'm going to start doing it a little bit more quicker and efficiently. I'm going to add 1 to both sides. So again, just b over 2 squared. All right, so 2 over 2 squared is going to give me 1. So I'm going to add 1 here. So x squared plus 2x, and there goes my plus 1. Okay, and then I still have the minus 8. So I better subtract out another 1. All right, don't put another plus 1 here. That's a very common mistake. You could put a plus 1 over here if you wanted to. All right, y plus 1. And then you're going to just have to subtract it out. So let's go ahead and get this squared. So this is going to be x plus 1 squared. And that's going to be minus 9. Well, that gives me a vertex of negative 1, negative 9. And axis of symmetry is equal to negative 1. So I'm going to go ahead and graph this. Let's go ahead and, there we go, drag this over. There we are. And I'll plot my negative 1, negative 9. Again, we have a very basic quadratic. And I'll reflect this point across here. And I'm going to need another couple of points here just to get a feel for it. I can sketch it, and it might be good enough for your college freshman class. But let's go ahead and get a little bit more precise. So I'm going to go ahead and find the x and y intercepts, the zeros. Well, one quick way of doing that is just simply factoring this quadratic of putting, I'm going to set, when you factor, you solve by factoring, you're going to set it equal to 0. So you're going to have 0 is equal to x squared plus 2x minus 8. And you're just doing this technique, which is very common in Algebra 1. What times what is equal to negative 8 when added together gives you a positive 2. And you're going to get 4, and if you were to split the middle, you're going to have 4 and negative 2. Well, with this leading coefficient of 1, your answer is just simply going to be x plus 4 times x minus 2, where x is equal to negative 4 and x is equal to a positive 2. Okay? So I have negative 4, 0. 1, 2, 3, 4. There's one of my zeros, negative 4, 0. Okay? And my other 0 is 2, 0. Okay? That gives me an idea of how to graph it. And we're going to go up like that. Okay, so there's our basic sketch. And you also may remember that you can find the vertex of a parabola given this, negative b over 2a and f of negative b over 2a. And we're going to use this on a frequent basis as well. Moving on to the next example. Now I'm giving you the zeros, and I want to write a couple of quadratic equations. Doesn't mean the only ones. We can have scalar multipliers and things like that, squishing it, stretching it. But we're just going to do a couple of basic ones. Well, we know one thing for sure. We have x is equal to 2 and x is equal to 4. All right? Because that's going to be our function. Here we have 2, 0, and 4, 0. X is equal to 2 and x is equal to 4. All right, so I can solve this or write the equation one a couple of ways, x minus 2 and x minus 4. All right, and I'm going to do the binomial multiplication. That gives me x squared minus 6x plus 8. Okay, and that could be y equal to, since this leading coefficient is 1, this one opens up. But we want one that opens down, so what we're going to do is we're going to multiply the whole thing by negative 1. So all the signs change. So we're going to have negative x squared plus 6x minus 8. Okay? And again, that's just one that opens up and one that opens down. Moving on. So here we're going to have a little bit more complex situation. I'm giving you the vertex and a point that passes through. Remember, a parabola is a set of all points that are equidistant from a foci and a directrix. And when we're dealing with quadratics, we have something very similar that we can play with the vertex and the point and write the equations as well. So let's go ahead and do that. I guess the first thing we want to do is just go ahead and write this in our vertex form, which again, a times x minus h squared plus k. And I'm going to substitute in what I know. And let's just go ahead and just substitute in the vertex first. It's going to be x minus 3 squared plus 4. Now what we want to do is we need to solve for a right here. In order to do that, I'm going to take this point 1, 2 and substitute it in for y and x. So in goes a 2. So I have 2 is equal to a, and in goes a 1, 1 minus 3. And there's my plus 4. And I'm going to solve for a. So that's just going to be negative 2 squared, which is going to be a 4. So I'm going to have 2 is equal to 4a plus 4. I'm going to subtract 4, so I'm going to have 4a is equal to negative 2. Therefore, a is equal to negative 1/2. Then I'm going to plug this back in, and I have my function, so f of x is equal to negative 1/2 times x minus 3 squared plus 4. And that pretty much knocks it out. So again, let's review the steps real quick. I'm going to write my vertex form, plug in my vertex, plug in my x and my y, and solve for a. Once I solve for a, I need to rewrite my function with my independent and dependent variables intact. So in goes the a, in goes my h, and in goes my k. Practice this a few times and you're good to go. Alrighty, I'll get this uploaded.